So our first learning goal today, let's go over here to the board where I write it. I can analyze graphs. Pick up where I left off, Harley.
I can analyze graphs. Can't read.
Okay, well then you can still be getting your attention, okay? Wait.
I can analyze graphs to determine the relationship between two variables.
Okay, that's the only one I want right now, just the first learning goal. That's the first one we're going to do. Analyzing graphs to determine a relationship between two variables. So that's what we're going to do in this activity 1 here on the sheet I just handed out to you. So it says plot each of the points from the function tables to make a graph that represents the function. Let's do that first, and then we'll do what the other thing is they tell us to do. So we need to go put these points on the graph. Now notice, on the x-axis, they have the what represented? Pounds. And on the y-axis, what do they have represented? The cost in dollars. So these are our x's. Let's put an x above that, and let's put a y above this. And those are our y's. So we really have here some ordered pairs. So we could do that in our table also. Do that to the first one anyway. We really have ordered pair 1, 6. The x value is 1, the y value is 6. So let's go put those points on our graph. You guys do it and I'll do it too while you're doing it. After I calibrate. So how many points should you have on your graph when you're done? 4. Yeah, you should have 4 of them.
Thank you.
Okay, so next let's determine the relationship that's going on then. What are the two variables in this situation? In other words, what are the two things that can change in this situation? The number of pounds, and what's the other? Okay, we're not going to just say cost like they did. We're going to say what? We got, what is the 6 and what is the 12 and what is the 18 and what is the 24? Is that, what kind of cost is that? Okay, it's in dollars, it's measured in dollars. It's the total strawberry cost, isn't it? Based on the number of pounds. So let's figure out also then what is going on in this table. What are we doing to the input to get the output? So what do we have to do to 1 to get 6? And the same thing has to be able to be done to 2 to get 12. And 3 to get 18. And 4 to get 24. Because there's lots of ways to get from 1 to 6. But we have to make sure that that same thing works for all of them. Harley?
Times 6.
Times 6. You guys agree that if we take 1 times 6, 2 times 6, 3 times 6, 4 times 6, take each of the inputs by 6, we'll get the outputs that they had for us? Okay? So when they're talking about the relationship, being able to, then it says, then write a sentence that describes the function, we're already told that strawberries cost $6 per pound. That's not what we're going to describe again. We're going to say what's happening between the relationship. So we're going to say the total cost, what is dependent, the output. So the total cost is, what did we do to the input? What did we do? So we get the output, the total cost, by doing what? Multiplying the number of pounds by, so we're going to say is 6 times, we multiplied by 6, the number of pounds. So the total cost is 6 times the number of pounds. What did we have to do to the input to get the output? How did each of those ordered pairs come about? And notice, we're really multiplying by the what? What does that 6 represent? What is that 6? Look at your papers, don't look at me. What is that 6? Caden?
Cost per pound.
It's the cost per pound. Those strawberries are $6 for every pound. So the 6 is the multiplier. Okay. Think about all the things you have to do, and you do the next one, number 2. Think of all the things we did up in number 1, and you do that in number 2. Show also what you have to do to the input to get the output, and then describe that in a sentence. Okay, anybody willing to share with me what you have to do to the input to get the output? Harley? Times 4. Okay, everybody agree, or does somebody want to challenge that? No challenges? Then I'm assuming you're agreeing with Harley? Okay. And then our writing the function in words, what could we write here? Sylvia?
The total cost is 4 times the number of gallons.
Okay, the total cost is 4 times the number of gallons, she says. Anybody want to challenge that before you? Just if you weren't done calculating, so anybody thinking differently? Okay, why do we multiply by 4 again? Okay, because the input is multiplied by 4 to get the output. What is the 4 actually representing? What is our multiplier representing? What's 4? It costs what? Per gallon. It's $4 per gallon. So that becomes the thing that doesn't change. But our input can change. And by the fact that we have to multiply it by 4 to get the output, that's our 2 changeables are the total cost and the number of gallons. Okay? So tell me then, without, since we already have the statement, the total cost is 4 times the number of gallons, how much would it cost you to buy 9 gallons of gas? $36. How do we get that? 4 times 9, yeah, 4 times 9 gives us 36, so we would say it would be, so once we know what the rule is, what the function is, we should be able to get other information from that. Okay, anybody have questions on that? But that's one of the things that you're going to be working with today. And I'm going to give you a couple more handouts here. We're going to be doing some transformations again. So these are going to work, we'll have these side by side, okay, because we will be working with graphs along with our Okay, what's our second learning goal today? Second learning goal, we're willing to read that one. Caden?
I can reflect shapes on
Okay, I can reflect shapes on
the coordinate plane.
the coordinate plane. What was the transformation we did last week with our shapes on the coordinate plane? What was it called? Translation. What happened with a translation? It was like a slide. You could slide left or right or up or down, right? It had 4 different directions it could go. Okay. So when we are talking about reflections, and can anybody tell me something about reflections without, you shouldn't be writing on your papers yet. We're just talking. Tell me something about reflections. Harley?
Like when you're driving in sunlight, your reflection on the ground is like the shape of what you are.
Okay. So there's a shape that is reflected. So are you talking about like maybe something like a shadow?
Yeah.
Okay, a shadow could be. A shadow is a type of reflection. Okay, tell me something else about reflections. Wait,
You can see yourself
you can see yourself. What can you see yourself in?
in a reflection.
In a reflection. Oh, so a reflection is reflected typically off of a what? A mirror, yeah. Okay, so, and does the mirror change what you look like? Sometimes we wish it would, but it doesn't, does it? No. Yes, Louis?
Also, if you lift your right hand, here you is lifting their left hand.
So it looks like your right hand in the mirror, but it's really your left hand? Okay. Because it's staring back at you, isn't it? Okay, tell me something else about reflections. Okay, there's something in reflections called a line of symmetry, or a line of reflection. So it has to reflect over something, okay? So it's going to reflect, and when our shape, since it's on the coordinate plane, the things we're going to talk about reflecting over our lines of reflection or lines of symmetry are going to be the axes, either the x-axis or the y-axis, okay? Our shapes are going to, it's not going to be like like shadows. Are shadows the same size as you? Not always, right? Because it depends on what? It depends on where the sun is located in the sky. Yeah, it depends on the angle of reflection, okay? So when we're doing these, though, our reflected shape will be exactly the same shape. It will just be reflected over either the x-axis or the y-axis. So looking at both your table and at your graph, let's look at number 1. We have this triangle, and right now they're saying it's in quadrant 2. Okay, let's go on that graph and let's label our quadrants. Let's see if we agree with them that it's in quadrant 2. This is where quadrant 1 starts, and then we go counterclockwise. So I agree that the triangle's in quadrant 2. Do you? Okay, what is it telling us to do with that triangle? Reflect it where? To which quadrant? Which quadrant? 3. It's supposed to go to 3. So that means if it's going to reflect to quadrant 3, which axis is it going to reflect over? The x or the y axis? It's got to come down here. It's going to, and another word for reflect, does anybody know another word for flip? I just said it. For reflect, it is flip. It's like a flip. We're going to flip this triangle over. It's going to be opposite direction it is right now. So it's going to reflect over the x-axis. So it's the x value is it the x value or the y value that has to become its opposite? Okay, let's put up here over x-axis. That's what's going to have to happen. So let's think about if it has to flip down over the x-axis. What would change, the x's or the y's? The y's would. The y's are the up and down. So it's the y value that's going to change, and it's going to become its opposite. Okay, so it's going to flip over to the x-axis. It's going to flip over the x-axis, and that y value is going to change to its opposite. So are the x's going to change? No, there's no sliding going on. We're just flipping over the x-axis here. So our x's, let's just start like this. All our x's are going to stay the same. They are not going to change. But the y values are going to become their opposites. So what's the y value going to be for a prime? What's the y value going to be for a prime? -4, because the opposite of 4 is -4. What's the y value going to be for b prime? -1, because the opposite of 1 is -1. And what's the y value for c prime going to be? -1, okay. So, let's go and graph those 3 points and see if it looks like we did a flip with that triangle over the x-axis from quadrant 2 to quadrant 3, okay? So go ahead and graph those 3 points and label them their primes, okay? And I'll get you some rulers so we can draw our triangles also. Okay, so not only are we going to put the A prime, B prime, C prime, but we're also going to write their ordered pair names beside those letters. So make sure you also give them their ordered pair names. Did we accomplish what we were supposed to? Did it end up in quadrant 3? Remember, a reflection is a flip over a line of reflection. Our line of reflection is the x-axis. So we should have a upside down triangle. Questions, anyone? Okay. If you're done with this one, will you go to number 2, and first of all, while you're still over here, maybe on the graph, or at least I'm over on the graph, let's first get our quadrants labeled. Anybody know what this figure is called in number 2? What is this? It's not a rectangle. It's not a square. It's not a trapezoid, but it's something that starts with P. Did that run it for you because it starts with P? It's a parallel. There you go, Sam. It's a parallelogram. It's a parallelogram. Okay, so I want you to go back now over to that other page looking at this also, and I want you to decide if we are supposed to reflect this to quadrant 4, what's going to be our line of reflection, or which axis? Make that decision first. And why don't you just write it right here? So you're going to need to go over which axis to get from quadrant 3 to quadrant 4. And then which value will change in the ordered pair, the x value or the y? Okay, so it has to go from 3 to 4. Which axis is it going to go over? The y-axis. It's going to reflect over the y-axis. So So if it goes from 3 to 4 across the y-axis, what changes from left to right? What changes, the x value or the y value? The x value changes from left to right. So the x value will become its opposite. So the opposite of x. So this time, it's all the x's that have to change, and all the y's are going to stay the same. So decide what all your ordered pairs are going to be, then go graph them. Draw your parallelogram and see if you were successful. And don't forget to give, first of all, just at least the letter name, the prime names to them. And be really careful when you're saying A prime, B prime, C prime, D prime on the graph. Because it would be very easy to label it wrong and then it would look like a different type of transformation. So when you're done, I don't have my coordinates labeled on here, but make sure that you have, before, I don't want mine to get too busy, before you do, I want you to make sure that you have your letter names in the right locations, your A prime, B prime, C prime, and D prime. Because that's just as important as being able to find the new coordinates, being able to label those points correctly. I'm going to do something. I don't want you to do this, but I'm going to do something, and I want you to tell me why I'm making such a big deal of this, okay? Okay, I don't want you working ahead on number 3. I want you with me right here, okay? So if you're finishing up number 2, that's okay, but if you're, I don't want you jumping ahead. Okay, I want you to tell me, do I have that labeled correctly right now? Or a reflection? No, there's, what would have happened instead? What type of transformation would have created possibly this one? Sam? It's a slide, yeah, it's a slide, a translation, because the A's just slid the same amount that B slid, but then, oh, wait a minute, then we have this little problem with these guys. They didn't really slide the same amount as A and B did they? So it kind of, it almost looks like there could have been a translation that went on, but, oh, wait a minute, there's also a problem with they didn't all slide the same amount. So it's really, really important that our labeling shows what type of transformation went on so that we're not confused with it. So we have to make sure that we, and tell me something, how could it's going to flip. So I know that this A has to go, it won't be in the same position, it won't be in the upper left, it's going to be in the upper right. And B is not going to be in the upper right, it's going to be in the upper left. It has to flip over to there. So I have to make sure that I am labeling these properly also. It's really, really important. Okay? And then I'll give my ordered pair names. What's the ordered pair name for A prime? 6, -1. What's the ordered pair name for B prime? Class? 2, -1. What's the ordered pair name for C prime? 4, -3. And what's the ordered pair name for D prime?
8, -3.
8, -3. Okay. Okay, let's do our last one. What is this one called? What is this? That one's a trapezoid. It has one side here on parallel sides. So this one's called a trapezoid. Okay, let's get our quadrants labeled. We're always going to do this until we're really, really sure of ourselves that we can do it without. And then it says, reflect the trapezoid from quadrant 4 to quadrant 1. Quadrant 4 to quadrant 1. 1's above. So which axis is it going to reflect over this time? The x-axis, okay? It's going to reflect over the x-axis. So it's going to go from quadrant 4 up to quadrant 1. What's going to change? The x values or the y values? The y, the up would be the y value. So the y value becomes its opposite, or in other words, a negative or the opposite of y. So the y values need to change, not the x values. Now, if you would rather challenge yourself to reflecting it and then naming their ordered pair names, you can try that too. But either way, we want their ordered pair names along with their new location on the graph. Okay? So go ahead and get those graphed or get this trapezoid reflected. And I'll do mine while you do yours. You guys can see your lines better than I can, your grid lines. And again, be really careful labeling their names. And when you're all done, you can check to see if you agree with what I have up there for it. And then I want you to take your paper, when you're done, I want you to take your paper and I want you to fold it on that x-axis. Actually, fold that graph right now, not with the other sheets, just this one. I want you to take it and I want you to fold it on the x-axis, okay? So fold the paper right there on the x-axis. At the y-axis, there should be a fold that goes up or down, fold it on the x-axis. And then see if you can tell me what should be true. If we did this right, what should be true when we fold it on the line of reflection? What, can you tell anything? What should be true? They should line up, one should lay right exactly on top of the other, right? Can you see that through your paper or not? Hold it up to the window like you have. Can you see it? It's a little hard to tell. If we've done it correctly, they should match, one should be exactly laying on top of the other. A prime should lay on top of A. B prime should lay on top of B prime. Oh, Sylvia was smart, she did hers to the inside. Does that make it easier to tell? Does it? She folded it in instead of out. Okay, so the line of reflection is like the fold line. It should make it so that one of them, the new one, lies right on top of the old one, okay? So, did you get that finished up? Questions, anyone? Okay, I'm gonna send staplers around, Miss Allen is gonna take care of it. I guess I could start one over here though too. I want you to staple these. Okay, what was the first one we did? First one was the tables with the graphs.